Welcome to another edition of Comet Algebra. This video is for Algebra 1, Chapter 2, Section 3, using the distributive property. All right, distribution is huge. We use it all the time, constantly in algebra, so this is a section that is really, you must understand it. So take notes, watch the video, and ask any questions that come up. The property for any real numbers a, b, and c. If you're multiplying something out here outside the parentheses times something in the parentheses that can't be added, like if it's x plus 7, you need to take this and multiply it times the b and multiply it times the c. That's why it's stating ab plus ac. So pretty simple, straightforward, and yet many different details come up with negative signs and what have you. Then after we do the distribution falls under the category of multiplying in PEMDAS. So if we have distribution in a problem and then we also are to be combining like terms, you do the multiplying first, which, like I said, is the distribution, and then the second step is to do the adding and subtracting, which is the combining of like terms. So it is a shift in your brain. You have to think in terms of multiplying while you're doing distribution, and then you stop and shift your brain into the add-subtract mode. So to define like terms, these are terms that have the exact same variables with the exact same exponents, and only like terms can be added or subtracted. So I'm hoping this is all a review from your pre-algebra, but we need to do some problems and get this concept very solid. In our first example then, there is no distribution, there is no multiplying, which is what I scanned through the first time, but I do see that I have some like terms. And we want to do the highest exponents first so that we can get our answer into standard form. So I underlined we have an x to the fourth term and another one here. These can be combined. 3x to the fourth minus 7x to the fourth, we do not change the exponents, we only do the adding and subtracting, is negative 4. 3 minus 7 is negative 4, and you just keep the x to the fourth. Then we have some other like terms here. We have an x squared term and an x squared term. 5x squared plus another x squared. 5 plus 1 is 6, so now we have 6x squared. And this x term has no other like terms to be combined with it, so we just keep it at the end. And you'll notice I put this in standard form, highest power first, and then descending powers. Here, again, scanning through, in example 2, looking for any multiplying and seeing none, we go right into combining like terms. X comes first in the alphabet, so I'm going to look at this x first. So I have 4x take away 3x. 4x take away 3x is 1x, but I do not need to write the 1. You can just write that as x. If you do put the 1 in there, it's fine. Next, I'm going to look at the y terms. I have 7y plus 8y. 7 plus 8 is 15y, again not changing the exponents. And then I just have this y squared term. Now I did put the y squared at the end, but at this level you don't really know why I did that. So I would, on a test, accept this if you put the y squared term first because you were thinking standard form. I totally understand. And we'll just learn more about standard form as the year goes on. In example 3 here, again, just looking for any multiplying. I am seeing none, so we go into the like terms. We have a 5x squared, so I'm searching for another x squared term, and I don't see any, so we're just going to keep the 5x squared. And it really wouldn't matter in standard form what I do next. I just happen to notice that I have an xy term here and an xy term, So I have 3xy's plus 4xy's is 7xy's. And this is an xy squared term, and there is no other term that has those same letters with those same exponents. So I cannot combine it with anything else. So that's your final answer. Example 4 now. Again, scanning through, looking for any multiplying. I see none. So now we're going to start looking for like terms. I have an x to the 5th term, just that one, nothing to combine with it. Now looking at this x squared y term, no other x squared y term exists. Likewise here, no xy squared term exists, and no other xy term exists. There's nothing to do here. This is done. That is the answer, completely simplified. Right, the purpose of looking at this example is to sort of demonstrate the associative property. Right now, the a and the b term are in parentheses together. They are not like terms, and they cannot be combined. So, to illustrate what we're really doing, when we combine these a terms, what we're actually doing is using the associative property to think about putting them together in parentheses and then doing that operation. So it's regrouping. And then I'm going to regroup these b terms together by putting them in parentheses. Now we don't usually show this step, but I'm showing it to you now so that you understand what we're really doing when we regroup. We are using the associative property and putting the like terms together. So 5a plus 3a is 8a, and b minus 2b is negative b. So that's my final answer. All right, in example 6, now we do have some distribution, which is multiplying, so this must be done first. So I'm going to put these little arrows in to remind me that I'm taking 2 times 7a. 2 times 7 is 14, and we still have the a as part of that term. And then 2 times 3b, it's positive 6b. And then in this second distribution, you must be very careful with your signs. This is a negative 5, and we're multiplying the negative 5 times 12b and the negative 5 times 6a. So negative 5 times positive 12 is negative 60b. Negative 5 times positive 6 is negative 30a. So that's the distribution step. Our brain was in the multiplying phase, and now you stop, and you really do have to shift your brain into looking for like terms. So now I'm looking at the a and the a term. And if I combine those, 14 minus 30 is negative 16. So I have a negative 16.
Just want to let everyone know.
Sorry about that. So we have negative 16a. And then we need to combine the b terms. So we take 6 minus 60 and get negative 54b. And then that's completed. Last example. Hopefully we can get this in before the fire alarms go off here at school. 3 times x squared is 3x squared. 3 times 2xy, 3 times 2 is 6, and we still have the xy. Now here's where it gets a little complicated because we have x times x in this distribution. So just to be clear, we're taking this negative 5x and we're multiplying it by 7x. So you do the number times the number and the letter times the letter. Negative 5 times positive 7 is negative 35, and then x times x is x squared. So when you're multiplying, you are working with the exponents. And then be careful with the signs here. Negative 5x times negative 3y. Remember the number times the number and the letter times the letter. Negative 5 times negative 3 is positive 15, and x times y is simply xy. Next step, we shift out of multiplying mode. Now we're looking for like terms. So we have 3 minus 35 with our x squared. So we have a negative 32x squared. And then with our xy terms, we have 6 and 15, and that would be 21xy. So really take your time and pay attention to details on this assignment. Ask your questions. We'll spend a couple days on this in class, and we'll do worksheets. This is very, very important to understand for what we're doing all throughout the rest of your algebra education. So hopefully you have the knowledge you need for section 2.3. So have fun with that.